All right. Welcome to the Friday seminar. Today we have an alumni from PSU, Michael Williams, and talking about roundabouts and road diets. So, Michael, all yours.
Thank you, Miguel. Today, before I get started, I want to make a couple of notes. I've enjoyed the weekly seminars here at Trek. They're great. They often are communicating really fundamental research that improves transportation and active transportation in particular. This is not one of those. This is more of a synthesis of information. So I just want to set the bar appropriately low before we get started. I think if we all learn a little bit, have a good time, I'll consider that a win. Today I'm going to talk about some work I did while I was here at PSU. Probably most of it was done about 2 years ago at this point. We're going to be talking about this concept. It's not a new concept, but it's not a very popular concept. The use of roundabouts with road diets. We're going to be looking at an aspect of the accessible guidance that I created and some observations I made while putting this guidance together that I think has inhibited the take-up of roundabouts, both in isolation and in corridors. And before I get started, I want to go on my soapbox about roundabouts a little bit. I'm always surprised when, especially active transportation colleagues, express opposition to roundabouts due to what they consider negative performance with respect to pedestrians and cyclists. And I would urge those who have bad experiences or hold poor opinions of roundabouts with respect to non-motorized users, I would urge them to consider that they may be reacting to poorly designed roundabouts or roundabouts that are designed for different goals rather than roundabouts in general. And if there are any students in here looking to ask questions about my presentation, that's an excellent area to ask me about at the end. Now here's our advancer. Let's see if this works. We'll get started. This is not working. All right, how does this, do I need the other one? This one isn't working either. Am I using it right?
Yeah.
This one, right?
Yeah.
I'll just do return.
Sure.
All right. So before we get started, a little bit about me. Degrees in computer science, electrical engineering, civil engineering. So I tend to come from a little bit of the engineering side. I do have some planning, knowledge, appreciation. I've had some experience in biomedical engineering, public works, general contracting, active transportation, about 10 to 15 years in each of those areas. Interests, safe streets, road diets, roundabouts, and my special interest, advisory bike lanes. All right, so we're going to refresh ourselves on what a standard road diet is before we go into the road diet version 2.0, or what I call road diet plus sometimes. The word road diet can be used to refer to any process where you reduce the number of lanes on a current roadway. But most commonly it's used to talk about a reduction from 4 lanes to 3 lanes, where you've got a 4-lane undivided road, as you see in the picture here, and it's converted to a 3-lane road with a lane in each direction and a middle lane which supports left-hand turns, known as a 2-way left turn lane, often called a twiddle, which I will be using throughout this presentation. Here's a plan view, schematic view, 4-lane undivided highway, converted to a 3-lane road. You obviously get some liberated right-of-way. In this example, they've put in bike lanes, unprotected bike lanes. So, standard road diet. Advantages where it's applicable. The current guidance, most popular guidance, FHWA Road Diet Informational Guide, tells us that up to 25,000 ADT on a corridor is suitable for a road diet. At least Seattle's a big proponent of these road diets, and they're applying them on corridors with that type of volume. There's been shown to be little capacity reduction on corridors, 4-lane undivided roads, which are already essentially functioning as 3-lane roads. If you consider a 4-lane road and people wanting to take left-hand turns, those inner lanes are often filled or used for motorists to stop or slow down before executing their left-hand turn. So those kind of movements reduce your capacity, and you often end up with a 3-lane road that can carry more traffic than the original 4-lane road could. Increased safety for all users. These 4-lane roads, especially when you got a lot of those left turning movements, can be quite dangerous. You have rear end crashes. You have side swipes when a car is trying to change lanes to avoid that car that's sitting there waiting to execute a left turn. So better safety. And you've got the right of way that's freed up from reducing travel lane. Which can be used to create bike lanes, it can be used to create bus stops, parking, whatever you want. And livability. Often a 3-lane road will calm the traffic a bit, slow down your speeds. The liberated right-of-way can be used to put in beautification components. Whatever a community wants to do to make that street a better street. But there are also disadvantages. They're not applicable to some corridors that might have short blocks. You may have signal timing issues, and you could, because you reduce the number of lanes, your intersection capacity goes down. And that may not be supportable with a road diet. If your 4-lane undivided road is truly functioning as a 4-lane road, where there are really no left-hand turn movements occurring, you do get a capacity reduction, and if you've got a corridor that's fully used, that capacity reduction might be significant. The road diet does not do anything to address safety at the intersections, nor does it do anything to address safety with your left-hand turns in the face of oncoming traffic. So these are important contributors to the safety of a corridor, which a road diet does little to impact. The right-of-way that's liberated with a road diet can be fairly minimal. Even though you're eliminating an entire traffic lane, the twiddle is often wider than a normal traffic lane, often 13, 14 feet wide. So you don't get that whole traffic lane back in terms of liberated right-of-way. And of course, a standard road diet isn't applicable to your higher volume corridors. So the question is, can we go one step or one lane farther? And of course the answer is yes, or I wouldn't have very much to talk about for the rest of the hour. I like to call it Road Diet version 2.0 or Road Diet Plus. And the great thing about this concept, there are no new elements, no new traffic engineering elements, no new planning elements. We have successful projects across the nation. But we're lacking both popular guidance and technical guidance, and the concept is not well known. There are a lot of roundabout practitioners that are well aware of this concept. It is becoming more popular. I think I just saw a post from Congress for the New Urbanism. Robert Studeville posted something on this, so it is starting to become more popular. But I think accessible guidance is one of the issues that are lacking. So what does a corridor look like when you've taken this 4-lane undivided road and applied this road diet plus roundabout treatment to it? What are we talking about? Well, first of all, we're talking about roundabouts, at least at all the major intersections. You can still have your normal cross-street intersection, but those are to be at minor road, intersections with minor roads only. It's a two-lane road. You only have 2 lanes, 1 lane in each direction. The twiddle is gone. You've got no left turns in the entire corridor, or very few left turns. If you're driving along the road and you go into the dry cleaner or the daycare and it's over there, you go up to the next roundabout, complete a U-turn, come back and take the right turn. So right in, right out. And while it's not necessary, a raised median helps enforce the no left turn. It gives you an opportunity for beautification, and it introduces traffic calming elements. So with my work, I concentrated solely on single lane roundabouts and 2-lane roads. There are examples of this kind of treatment where they've used larger roundabouts and more than 2-lane roads, but I did not look at that. The advantage of this kind of treatment is that the safety impacts are dramatic. One of the things that I love about roundabouts is their incredible safety record. You look at the studies out there, a normal intersection, signalized or not, is twice as likely to 10 times as likely to kill you or maim you as a roundabout is. And they tend not to be used as often as I would like to see them used, but I consider them a critical element in the whole Vision Zero approach. The FHWA has listed them as one of the proven countermeasures. And so the safety impacts of roundabouts are incredible, and I think can't be overemphasized anywhere. You've also got the removal of left-hand turn lanes, or left-hand turns in the face of oncoming traffic. I think if I remember correctly, in the last, might have been 2015 national crash statistics, a left turning movement was the 3rd most common action occurring during crashes. And I can't remember if those were fatal and severe injury crashes only or if it was all crashes. But it's an important component and one of the crash types that give you the most severe injuries and fatalities. So the safety is off the charts. Liberated right-of-way. I mentioned that earlier road diets didn't give you all that much right-of-way. You got less than a travel lane out of it. But this one, you're going from 4 lanes to 2 lanes, and they're both normal-sized travel lanes. You get a lot of right-of-way. You can do some pretty incredible things. Protected bike lanes, bus stop plus bike lanes, parking, a lot of room there to make improvements, beautification, traffic calming, et cetera. You go slower and you get there faster. A report, NCHRP 772, I think that was 2014, they looked at a number of these roundabout-based corridors. And what they found is that when you take a corridor and you get rid of all the signals, traffic signals, and replace those signals with roundabouts, is that everybody's moving more slowly, but nobody's waiting at the intersections. You're cruising through the roundabout, you slow down, but you're always moving. So the unintuitive take, or what's shown in this report, is that you're going slower, but you actually get to where you're going sooner than if you were waiting at these traffic signals all along the way. So that's another big benefit for people who are more vehicular oriented and are concerned about throughput. You get reduced speed in these corridors. Your noise level goes down. Cars not waiting at signals produce fewer pollutants, so your air quality goes up. Your corridor becomes much more livable. You got the right-of-way, which gives you place-making opportunities. And in a lot of these corridors that have been studied, people buy more stuff. Commerce goes up, People want to be there. They go to stores that are there, and they make businesses happy. Short blocks and signal timing. I say no problem here. Well, that's not completely true, but they're much less of a problem than if you're using a conventional road diet approach. So you don't get anything for free. What are the disadvantages of this road diet 2.0? Most of them are issues that need to be dealt with roundabouts in general. Number one, you've got small roundabouts, which means your larger vehicles may have issues getting around the roundabout. They may only be able to take a left-hand turn. Doing a U-turn may not be possible in some cases. That could be a problem if you've got a corridor where there's a lot of freight coming through. But there are ways to deal with that. Emergency vehicles and public buses, those fire trucks in particular, those can have issues, again, with turning and or traversing a mountable island. A roundabout's capacity is dependent on rates of left turns and U-turns. So you've got so much capacity in that circle, and if you have a whole bunch of people coming in to do a U-turn to come back, you're going to reduce the capacity of that roundabout. So that's just something you have to take into account. Capacity is also dependent on familiarity with roundabouts. And this is something I'll get into in a little more detail further on. But there is quite a big difference between the throughput of European roundabouts and the throughput of American roundabouts. And it's not based on design factors, it's based on the fact that Europeans have likely grown up with roundabouts, familiar with them, know how to use them well, no big deal. American roundabouts, drivers not as familiar in most places, and their ability to smoothly merge into that traffic flow is less honed than their European counterparts. So you get less capacity. Also with this corridor style, as you see in the picture here, your ability to pass, if you have a truck parked to deliver boxes of goods, there's no way to get around it. Also, if you have a bus stopping to pick up passengers, no way to get around it. So there are measures you can take to deal with that. You can have loading zones, you can have bus stops, bays that allow buses to pull out. Or in some cases, in fact, the case, this picture here is of La Jolla Boulevard in San Diego. They just said, yep, sometimes you're going to have things parked in the travel lane, and they chose to take that hit. Also, corridor friction, and this is a plus minus kind of setup. And what I mean by corridor friction is you've got a corridor that's more attractive to people. So you're going to have people crossing the street, you're going to have cyclists riding to the local store or pub. And so you've got more non-motorized users there, friction, which impacts your capacity, but overall capacity in terms of people moved, actually higher. So when I looked at this concept, and having been a recently converted roundabout fanatic, I couldn't understand why this concept wasn't just taking over. And so I looked at what existed out there, and I realized there's no accessible guidance for this concept. There's actually not a whole lot of technical guidance either, but to popularize this idea, to make it more accessible, to make it, to encourage its adoption in a more widespread manner, I thought what we needed was a little bit more accessible guidance along the terms of FHWA's Road Diet Informational Guide, which has a feasibility process and some explanatory material for people who may not be as engineering oriented, but who may be important stakeholders in the process of deciding what to do with a corridor. So I set out with my work to create a counterpart to that guide. I just went ahead and mirrored the FHWA Road Diet Informational Guide, defined the concept, talked about benefits and trade-offs, feasibility of this approach, design issues and assessment. And what I'm going to be talking about today is the feasibility assessment part and the work I did to come up with a cheap and easy process that people could use, say, hey, I got a corridor here. I want to do something fantastic with it. Is it feasible? And a little bit of a spoiler here. What I did came out great, but even so, it's a little too conservative, and we'll talk more about that. So how does an agency know if a road diet 2.0 is worth doing? Well, the two major questions are, is there room at the existing intersections to place a roundabout there? One of the big barriers to tackling this kind of renovation is if you do a roundabout, roundabouts tend to be larger than normal intersections, whereas the roads in between them can be smaller. If you're having to buy buildings and tear them down, or buy businesses and close them, number one, you might have a lot of public opposition, and number two, it's going to be pretty darn expensive to do that. So you need to know what's involved in terms of right-of-way required for those roundabouts. And number two, what are the supportable traffic volumes for this kind of concept? You know, if I've got a busy corridor and I want to do this fairly radical concept and commit to trying to convince stakeholders that this is an idea worth considering, I've got to know that that final plan is at least going to be, it's going to at least have the possibility of supporting the volumes that you're wanting to support in that corridor, either now or in the future. So the first question is, how much space do you need to put a roundabout? And this is why I chose to address single lane roundabouts only. They're smaller, obviously, and they're going to fit within existing corridors much more readily than their larger brethren. In talking about roundabout categories in terms of sizing, I go back to the 2000 guidance on roundabouts, where they had a taxonomy of roundabouts, which disappeared, unfortunately, in the 2010 guidance. They had a split of their categories down at the bottom end. They featured an urban compact roundabout, which is 80 to 100 foot ICD, which is a term, I'm going to blank on the name now. It's a diameter from curb to curb across the roundabout. And that's the usual way one measures the size of a roundabout. So you've got an urban compact roundabout, which is a single lane roundabout, fairly small, may have limitations in terms of larger vehicles and turning. And then you've got the one step up from that called an urban single lane roundabout, a bit bigger, fewer restrictions, a little more capacity. And so those were the two categories of roundabouts I chose to consider for this work. What I wanted to do was create a roundabout template. So if you were wanting to take a look at a corridor and see if there was room for a roundabout, you'd say, well, I've got this kind of volume, because roundabouts, their size is directly related to the volume you want to carry. If someone is wanting to evaluate the right-of-way needs, they'll take their volume, take a look at this template, and evaluate what kind of impacts that approach is going to have on each of their intersections. Excuse me. So I have a procedure here for coming up with a roundabout template. Take a look at a number of examples. I wanted to include the sidewalk and landscaping, which is obviously normally needed for a roundabout, but which the ICD doesn't capture. Surprisingly enough, they're To my knowledge right now, there are no roundabouts in the US with separate bicycle facilities around their circumference. There are roundabouts with that have the opportunity for cyclists to merge up onto the sidewalk and traverse the outside of the roundabout in that manner, but none have separated bicycle facilities at the moment. So that was just an extra bit of distance that you'd have to add on. Second question is, what kind of traffic volumes can this type of corridor support? When I thought about how I was going to figure that out, I took a look at 3 different options. There was simulation using tools like VSIM or SIDRA. But these are very specific to a particular design, and they're difficult to generalize. The second was using formulas available in the Highway Capacity Manual, but those formulas don't really work all that well in corridors, and they're really essentially based on current American throughputs. I mentioned earlier that Europeans use their roundabouts much more efficiently than American counterparts, and the current HCM models don't show that potential. So the third one was take a look at some corridor that's already been renovated in this manner and see if there might be some on-the-ground data that would tell me what these corridors can do. So I chose number 3 because I did find some good data. And in fact, the data was so good that it illuminated some drawbacks to existing roundabout throughput guidance, which, as I remarked at the beginning of this talk, I think has really been retarding the uptake of roundabouts in this country. So what kind of data did I look at? NCHRP 772, great study. It's limited only to throughput, which is unfortunate because there are so many advantages to these roundabout-based corridors. But they had a database of roundabout corridors across the nation, and that was crucial for what I was doing. So from their database, I looked for roundabout corridors that had at least 3 roundabouts in series, 2-lane segments, 2-lane roads, rather than wider roads, single-lane roundabouts only, and didn't include a pair of roundabouts at a highway interchange, which is often something they do, which turns into a corridor, it looks like a corridor, but really it's a highway interchange serviced by roundabouts. So after using that criteria, I came up with 6 corridors that I want to take a look at. La Jolla Boulevard in San Diego, Pagan Ranch Road, Boynton Beach, Florida, Maple Island Road in Springfield, O'Neill Drive in San Juan Capistrano, West 8th Avenue in Chico, and Via Bella Street in Pennsylvania. So I took a look at those characteristics, and I won't go too much into the details, but out of all these roundabout corridors, I chose 2 roundabouts which were representative of both the urban compact and the urban single lane roundabout. Their characteristics reflected the mean of roundabouts in that category and were examples of good use in that type of application. So moving on to the second question, what kind of traffic volumes can we expect in the corridor? One corridor leaped out in particular, and that's a very famous example of La Jolla Boulevard in San Diego. Now, what they had in San Diego was actually a section of Highway 101, which went right through their central business district. It's really a neighborhood of San Diego, the La Jolla area. Bird Rock is also what it's referred to as. But they had 22,000 cars coming through their business area downtown every day, 40 to 45 miles an hour, 5-lane road, as you can see from the picture. And people got fed up with it. They didn't like it. The term auto sewer, I think, would be well applied here from the looks of things. It just is not an appealing place to be. So people demanded better, they were upset, and they got better. Starting in 2008, they had a complete renovation of their corridor, led by Dan Burden. And it was the classic, this road diet version 2.0, 2-lane road, hard median, no left turns, small, in this case, urban compact roundabouts. All kinds of great things. They put in bike lanes, they added parking in some areas. And now, back 2 years ago when I got the data, they're supporting 23,000 vehicles a day, much slower speeds, 15, 25 miles an hour. Roundabouts this small require you to drop down to 15 miles an hour to negotiate them. 77% noise reduction, 90% decrease in fatalities. As you can imagine, driving along on this kind of road and driving at 15 to 25 miles an hour, it's just so different from the previous picture. The fatalities, the driving behaviors, it's a completely different story. So a huge turnaround in this community, which improved commerce, livability, gave placemaking opportunities, just fantastic success. But when I looked at the volumes in this corridor, I found something that didn't fit. So actual volumes, I got traffic count data from the city. Essentially boiled down to you get between 1,100, 1,200 vehicles an hour on these tiny little roundabouts. And in this NCHRP 772 report, anybody else see that thing moving? In this NCHRP 772 report, in the interview with the City of San Diego representatives, they said they had simulated the corridor at up to 27,000 ADT, which comes into about almost 1,400 vehicles an hour. But if you look at the Highway Capacity Manual, the Bible for traffic engineers in this country, the most you should expect from a roundabout is only about 1130. And this is ideal conditions. This is not worrying about pedestrians crossing the road, worry about cyclists. This is only cars, ideal conditions. Numbers up here, you got peds, you got cyclists, you got real friction. So what's going on? This is, it didn't make sense to me. Something was off, given the difference in the range of numbers and the fact that the models predicted much less throughput than what we were actually seeing with lots of real life impacts on the volumes. And in learning more, what I found out was that there were two issues here. The first was this corridor had low left turn rates, and their minor streets coming into the roundabouts had fairly low volumes. So if you think about it, a roundabout that's primarily supporting through traffic really becomes just a traffic calming element. A little bit of horizontal deflection and you're on your way. So that could help explain why roundabouts in this corridor were showing performance that wasn't predicted by the model at all. But really what the key element, the key to the difference here is that the models that are used in the Highway Capacity Manual were created by looking at American drivers going through roundabouts. And so when you take capacity, a capacity model that's based on a driver that's unfamiliar with a roundabout, you're going to get lower capacity, as I talked about before. So what happened is the model assumes unfamiliar drivers to some extent. You get a corridor where people become familiar with the roundabouts, start learning how to use them more efficiently, you get this difference between actual volumes and what the models predict. So here I'm going to jump over to a little bit, talk about the models and their progress. Back in 2000, first Roundabouts informational guide, they had no model, but they said, hey, as soon as performance data for these roundabouts start becoming available in the United States, we can use that data to create the models. 2007 roundabout, NCHRP report, created a model. Here's that 1130 I talked about earlier. That's the max throughput you can expect from a roundabout. This is also the formula that's used in the Highway Capacity Manual for 2000. 2010 roundabout informational guide, second edition, same model, no change yet. Also 2010 Highway Capacity Manual, same model. So we're still there, but 2014 NCHRP 772 report, the roundabout corridor study, they started saying, hey, something's not right here. We're seeing a difference. They acknowledge the shortcomings in the current capacity guidance. They created a new model for roundabout corridors. Works differently than the models previously, which only looked at roundabouts in isolation. So they're working towards something that's more applicable to this environment. Finally, in 2015, around about the time I was doing this work, a little before, there was a series, a 7-volume series, whose goal it was to accelerate the use of roundabouts in the country. And one of their volumes took a look at roundabout capacity models. And they acknowledged that the Highway Capacity Manual underestimated roundabout capacities and recommended a new function for predicting capacity. And if you look at the maximum there, 1380, that lines up quite well with what the city of San Diego said their simulation showed, I think 1374 if I remember correctly. So we're starting to see the guidance catch up with what's happening on the ground. So all this work on the feasibility assessment portion of the traffic guidance kind of distilled into this table here, which just tells you that if you pick your desired throughput for your corridor, and I had to split it up by percentage of left turns and U-turns, because that's the model or paradigm that my data could support. This guidance tells you what size of roundabout you need to support that kind of traffic volume. So that's your feasibility assessment. And I would kind of taper off here and tell you about the accessible guidance I created and encourage everybody to spread the word. But just a couple weeks ago, I'm talking to a traffic engineer in New Zealand, big roundabout fan, Duncan Campbell. Thank you, Duncan, if you happen to be watching this. Tells me about a roundabout in Henderson, Auckland, New Zealand. Blew my mind. All right, so I'm talking about, and let me go back to, if I can. Oh, now it works. I forgot to make a point here. Where did I pass my table? There we go. The point I forgot to make is that these throughput levels, current roundabout guidance, currently says for an urban compact roundabout, you should only expect 15,000 vehicles a day. Single lane roundabout, 20,000 vehicles a day. So current roundabout guidance significantly underestimates how many cars you can get through, which is what I was referring to when I said, hey, I think current guidance is really retarding the uptake of roundabouts, both in isolation and in the corridor experience setting. So this is significantly greater than what we're seeing in the current guidance. But this blew my mind. This is actually what's called a mini roundabout. There's no raised island here. This island that you see might be 3-4 inches high, but it's traversable by larger vehicles. So big trucks, fire trucks, can make the turn through the roundabout. This mini roundabout is pushing 30,000 cars a day through this thing. And it's not in a heavily urban corridor, or it is in a heavily urban corridor with lots of non-motorized users. This is a big shopping center here. I don't know what the other land uses are, but on Duncan's website, he has an hour-long video showing this roundabout. Plenty of people walking, cycling through this thing. But the key to this, or the amazing thing to me, is this mini roundabout is smaller than the urban compact roundabout. And in current guidance, at least for this country, they say to expect only 10,000 cars a day through a roundabout like this. They're doing 30,000. He says there are some queues that develop at peak times. It says about 100 meters, so 10 to 15 cars maybe. But that's only at peak times. So you've got a mini roundabout supporting 3 times the kind of volume the current guidance shows. It has some interesting characteristics. Number one, you've got these bypass lanes, which help support the high volume, which may or may not work in all situations. But the thing that I find really interesting in this is that you see, and now we're getting into a little bit of the roundabout especially, there's not a whole lot of horizontal deflection for some of the cars coming through this roundabout. Horizontal deflection is key in a roundabout. That's what slows people down. That's what makes them so safe. So what they did in this case is they raised the entire roundabout, raised intersections. You've got essentially a big speed table. So what they're doing is they're trading off between horizontal deflection and vertical deflection to create a roundabout that's quite small, but still has the traffic calming impacts of a more normally designed roundabout. So this showed me that what I have put together is even still too conservative, besides being quite a bit beyond what current American guidance shows. I think we can go even further. But I just learned of this, haven't had a chance to look at it much, but it's exciting and shows the potential to go even further. So here I'm winding up. This is where you can find my accessible guidance. I call it Road Diet Plus. In this document, Road Diet version 2.0, I use it interchangeably. Again, not a new concept. It's been out there, just not very popularized, maybe not as well known as it should be, really. And thank you. And any questions?
Is it possible that a roundabout can only be an intermediate improvement as traffic increases?
Notice there are some, the roundabouts in this area are mostly out in rural areas. They don't get a lot of traffic. I haven't noticed many roundabouts. Like the only one
When you say this area, you're talking about Portland?
Yeah.
There aren't very many roundabouts in Portland. Probably the best known non-roundabout that people think is a roundabout is up north here. Anybody know where I'm? I think it's on MLK.
Yeah.
Cesar Chavez, that's it.
Yeah, that's the one.
That's not a roundabout.
not?
Yep, not a roundabout. There is a roundabout out by Lewis and Clark College. There's one or two others, but I don't remember where they are. But the one you're referring to that most people think of in Portland when they think of a roundabout is that problematic traffic circle-ish intersection.
Well, the reason I ask is because there's a roundabout on Borland and Stafford by I-205, and traffic, you can get back well over a mile during rush hour. And it seems to be because there's a high traffic going this way, and you want to get onto the freeway, but there's light traffic circling around, trying to also get there.
Right.
And they have a hard time finding gaps between traffic. It almost seems to me like it would improve by having an actuated traffic signal.
So that can be a problem with roundabouts. If you've got one heavy movement that dominates and you've got additional traffic circulating, you can overwhelm the roundabout. That can be addressed in a couple of different ways. You can have what are called bypass lanes, which essentially allow that traffic to completely avoid the roundabout. So you're separating that flow from the roundabout proper. Those have pluses and minuses. If you've got some bigger flows, you can look at other options like signalization is a potential. But I don't know the roundabout you're referring to, but there are options for dealing with that kind of problem.
So you pointed out the mini roundabout in New Zealand. Have you seen any examples of just those raised medians, but not anything better in the US?
With mini roundabouts?
Yeah.
I haven't. I know I haven't looked at mini roundabouts much at all. They tend to be dismissed almost as just neighborhood traffic calming and not really considered to be viable candidates for corridors per se. So I don't even know if such a corridor exists. I don't know one.
The main example you used has a raised median, and I was wondering about those, and they bring up good opposition to the change of not being able to do left turns and how communities have mediated that.
Public opposition is a concern for roundabouts in general. Raised medians do present an additional challenge. There are other examples of this kind of treatment in the US. I'm not very familiar with how they dealt with public opposition to that kind of treatment. I know in looking at some of these other corridors that some of the corridors did provide left turn lanes at certain points along the corridor, so I assume that's because of either simulation studies showing that to be a more effective way of dealing with the volumes, or possibly a well-placed public opponent, or who knows. It's very situation specific, but I don't really know much about how they dealt with public opposition.
During rush hour, how can we ideally control traffic flow? Is there like a priority for some lanes or first come, first served?
No, it's pretty egalitarian. You take your place in the line and you get into the roundabout when it's your turn. That's how they work. I see a question over here.
Yeah, so I have a question from one of our online viewers about if you can elaborate on what is still the biggest obstacle in implementing more roundabouts here in the US?
I asked that question of Lee Roadgertz at Kettleson, who's a leader in roundabouts. And he said, and I hope I'm remembering this correctly, I'll paraphrase it to become my answer. Money and familiarity. Like I said, there's public opposition to roundabouts, fear of change. It's a new thing. despite having overwhelming advantages, less delay, safer by an order of magnitude, they're just incredible, right? But still, they tend to be not used as much as they could be. Part of that, a small part of that reason, I think, is this underestimation of throughput capacity that will hopefully be addressed at some point. There's a third edition of the Roundabouts Informational Guide coming. I think they're letting out the bid or the proposal here soon. And hopefully the roundabout throughput capacity issue gets addressed, as well as other issues. But we'll see.
Thank you, Michael. I have just two quick questions. One, it is this kind of talking about capacity by time, by hour, and then per day. So what is the assumption about the distribution? Obviously, it is, the same traffic throughout the day is great, but what about, these arterials with peaks and, like, and the other one is, so what about bus stops? Typically there is always a discussion about near side, far side location, signalizing, etc. So when you have these corridors, maybe no one asked this question before, but it's kind of very. So is there any idea about what might be better, near side or far side?
So I'll take the second question first, and then you can remind me what the first question is after I'm done with the second question. I've seen a little bit about bus stop location on roundabouts, but there isn't much. And I should have suspected that you would ask a question like that. But no, I haven't seen much. I think with regards to this kind of treatment, you're probably going to need to have bus bays, especially if you're trying to support higher volumes with this kind of single lane treatment. Normally, a lot of people say, no, the buses stop in the traffic lane. It's public transit, they have higher priority, but I think in this case, you're probably going to need to go with the bays. And I would imagine that finding places for the bay, appropriate siting for those bays would probably be more of a determining issue than before or after, but I don't know, I haven't looked at that, and that's not my area of expertise at all. And your first question was what again?
About the assumption about the distribution of traffic.
Right, okay. So, and that's a very good question. When I looked at the data for the La Jolla Boulevard corridor in San Diego, one thing that leaped out is had a very characteristic commute pattern, and I think that's what supports this idea of familiarity, raising the throughput capacity of these roundabouts. You've got people that are going to and from work every day. These roundabouts have been in place for 10 years approximately now. So the people that live there have become very accustomed to using these roundabouts. They know how to just slip right in, and that's one of the reasons that these roundabouts are performing so well. I did not find a corridor which had higher volumes, which had more recreational or more average, a more evenly spread volume, but it's very commute oriented.
Foster Road is scheduled for a diet. Would it be a candidate for roundabouts?
I don't know. I don't know much about Foster. It really, roundabouts, and particularly this this approach, it relies a lot on what kind of traffic movements are occurring. Is there a heavy left turn? Is there a heavy right turn? Are they mostly through travelers? So it depends on what the volumes are, what the things those cars are doing, etc.
It's a diagonal too. Is that complicated now?
That's a good question. I don't know is the answer. I've never thought about that. Good question.
I was wondering about treatments that enable freight to move through, or if, I was wondering with the Lafayette Boulevard, if that's just not used very much as a freight corridor and more used more as a commuter corridor, and that's why some of those changes were put in their way.
They do have freight on that corridor. It's also a transit corridor.
Okay.
I talked about them just being willing to take the hit for buses stopping in the travel lane. They did that. Buses stop in the roadway, pick up their passengers, and get rolling again. There is a parallel street. And again, it's been a while since I did this work, so I may not be completely accurate about this. There's a street that they've improved in parallel, and I forget the extent of the improvements or the type of improvements, but that street also helps carry some of the freight load. There are some restrictions on larger vehicles turning at some of the roundabouts on this corridor, but I can't tell you exactly what those are. Okay.
So I guess time for one final question is, you said that familiarity really is a big variable in terms of how much volume can go through a roundabout, and also it contributes to the potential safety implications here in the US. Aside from the fact that people in Europe grow up with roundabouts, and whereas people here did not, what are good ways to familiarize people with how to use roundabouts?
Build more of them. That was a little bit of a facetious answer, but I think it's also has an element of truth to it. Part of the reason we're less experienced with roundabouts and use them less efficiently is we don't have much experience with them. There are places in the States, Bend, Oregon is a nearby example, which Carmel, Indiana, I think it's in Indiana, a community which has just gone whole hog on roundabouts. You just need to get used to them. You need to drive them. That was the last question.
Yeah, thank you.
All right, well, thank you, everybody. Thanks for